We now, using the ideal gas equation, can find moles of a gas. This allows us to look at reaction stoichiometry and using the ideal gas law, convert to moles of a gas. Quite frequently, when we have reactions, the amount of gas is given as a volume. So in that case, we have to also have the pressure and the temperature in order to determine the number of moles. But using our ideal gas law, with the pressure and the temperature, we can determine, and the volume, we can determine the number of moles and then use the coefficients in front of our balanced chemical reaction to relate to the moles of a gas to another substance. Additionally, if that reaction happens at STP, we can use the conversion of 1 mole equals 22.4 liters, simplifying our math. So let's try an example where we're looking at a chemical reaction involving gases. We want to find the volume of hydrogen that is needed in order to make methanol. Because we're given grams, we can convert to moles to use our balanced chemical reaction. So 35.7 grams of methanol. Using the molar mass, we can add up the masses of our carbon, our hydrogen, and our oxygen in order to find the molar mass, which is 32.04 grams for 1 mole of methanol. Using our balanced chemical reaction, we can use the coefficients to convert to moles of hydrogen. So 1 mole of methanol requires 2 moles of hydrogen gas. We find that it takes 2.2284 moles of hydrogen gas to make 35.7 grams of methanol. But we're trying to find a volume, not the number of moles. So now we can convert, using our ideal gas equation, into a volume. We are going to have to do a conversion for the pressure. 738 millimeters of mercury. No, there's 760 in 1 atmosphere. So we have 0.97105 atmospheres. Now we can use our ideal gas equation, solving for the volume. In order to find the volume of the hydrogen. So we know the moles. We solve for that using our dimensional analysis. The ideal gas constant times our temperature, all divided by our pressure. And if we solve our equation, we see that our volume is 66.9 liters of hydrogen are required. Here's a practice problem for you to try. See if you can figure out the volume of oxygen required for the thermolysis of 10 grams of mercury 2 oxide. Thermolysis is the decomposition or breaking apart using heat. Pause the video and determine the volume. If we have 10 grams of mercury 2 oxide, or given the molar mass, we can convert to moles. Now that we're in moles, we can use our balanced chemical reaction to convert from moles of mercury 2 oxide to moles of oxygen. We see that we end up with 0.023085 moles of oxygen. Now we can use the ideal gas equation, solve for volume, in order to determine the volume. So we just solve for the number of moles. R is our ideal gas constant. T is our temperature, all divided by the pressure. So our volume would be 0.791 liters of oxygen.